start 3.1 by looking at some interpreting, analyzing graphs, and then pretty quickly we'll get into the rectangular coordinate system. But for the first example, I'm just going to go through a basic line graph, and so this is kind of thing you might see a few of these in your homework. But right off the bat, I do have a typo that I thought I had fixed, and I obviously didn't. So it's right here in this first example. It said how far, so we're supposed to use the given graph here to determine how far the walkers had walked, not in 3 minutes. The label on this graph is in hours. So if you could please change that label to hours for me, that would be lovely. All right, so how far they walked after 3 hours? Well, that's our looking at on the horizontal axis going to 3 hours, and then we're going up, and we can see that at 3 hours right there is that point, and take that over, and it looks like the distance that they have traveled at that point was 60, I'll say I'm not sure, meters perhaps. If it's a whole group that are maybe doing a walkathon for charity, maybe the collective whole group of them had walked 60 miles by that point. That seems reasonable, but I'm not 100% sure, so I'm just going to say 60 m on that one. Okay, so just a basic reading and interpreting of this graph. When then did I guess I am assuming miles here, when had the walkers reached 70 miles? So now we're looking at the 70 on the vertical axis. So, in the last example is a little different. We were given the 3 hours on the horizontal axis, and then we use that to kind of go up and see then what that y coordinate was. This time what we have is we are looking at the 70 miles that is on the vertical axis, and now we're taking that out on our graph, and so it looks like we're going to have to estimate that one just a little bit, and then we're just going to have to again estimate kind of what that value would be on the x-axis or on the horizontal axis. So this is going to be an estimate. I'm going to say approximately maybe 6 2/3 hours, so maybe roughly around 6 2/3 hours, or 6 hours and 40 minutes. Okay, part C, describe in practical terms what happened from the 3rd hour to the 6th hour. So between the 3rd hour and the 6th hour, the graph is horizontal. We're not increasing our distance at all. So I would say if we're talking about a group of, again, walkers, maybe for charity, they didn't add any additional distance over that time. So maybe the group of them took a break for whatever reason. They weren't doing any walking at that point. Who knows? Maybe there was a storm and they had to take a break. Okay, part D. Over what 3 hours, 0 to 3, 3 to 6, or 6 to 9, does the graph show the greatest increase in miles gained? All right, so if we're looking from 0 to 3, it looks like they gained approximately, that one's pretty easy to look, we kind of already answered that. Looks like they gained approximately 60 miles on that. And then from 3 to 6, I don't even think I need to say approximately on that. That was a pretty exact value that was given, 60 miles. And then from 3 to 6, well, that one we just answered as well. They didn't gain any miles over that time frame. And then from 6 to 9, if we were to estimate that, looks like they ended at 90 miles and they had started at 60. So that looks to be a gain at 30 miles. So definitely the largest increase was in this region right here from the 0 to 3 hours. So that would be our answer on that. Between 0 and 3 hours is when they had the greatest gain. All right, the last question, it says, what was the average speed over the entire 9 hours? All right, so as we look at that one, we want to think back to that formula we used a lot in the previous chapter when we did those motion problems. So speed is just rate, and we know that distance is equal to rate times time. So we're looking for the average rate. So if we wanted to, maybe the first thing we would do is just think about solving this formula for r by just dividing both sides by the t. And so that's going to tell us that the r would equal that entire distance divided by time. Well, over the whole 9 hours, if we scroll back up, they achieved a total distance of 90 miles. And again, that was over a 9-hour time frame. So that means just doing that division, this is 10 miles per hour. So that would have been their average speed. Obviously, they were fastest in the first 3 hours. They didn't do anything in the second 3 hours, and then they were a little slower in the last 3 hours, but on average, they averaged about 10 miles per hour. All right, number 2, let's interpret a little bar graph here. So this graph is which countries have, or it's a graph that is entitled the incarceration rates. So it's the number of prisoners per 100,000 in the population. And again, it's a little dated, I do apologize, in 2005. So one of the things that I would start off in class, I'd ask students to critique this graph. One problem I have with this graph straight up is the title is country, and then down here they throw in Europe. And so let's just point something out here. That is not a country. So they could have maybe titled this a little differently. So here's just a little critique of this graph. Maybe they should have just said in various regions over the globe because Europe is not a country. Okay, so which countries have the largest incarceration rates? Well, pretty quickly we can look and see the countries at that time. From what I've heard, I think that the United States has definitely gained in that particular category. But at that time, it was the countries of China, India, and the United States. Okay, now, part B. Why is the title, incarceration rates, prisoners per 100,000 in the population, so important here? And this is really important. So we can't just look at the absolute number of incarcerations, like how many people are in prison in different countries, because countries with large populations would naturally have more people in prison because they're bigger countries. Countries with smaller populations would naturally have less people in prison. So that's why we have to look at the number of people in prison per population. So the reason is because we're comparing, so in this case we are comparing, what they're calling countries, they also throw in the entire continent of Europe, but because we're comparing countries with different populations. So when we're comparing countries of different populations, we need to look at a rate to kind of level that playing field. So you might be tempted to look at China, India, and the United States and think, well, yeah, they're going to have a lot. They're big countries. But that is not what's going on here, because this is already taken that into account by looking at incarceration rates. All right, last part of this one is just a specific interpretation for, in this case, the United States. And so we're going to assume that's right around, it looks like, a height of 600. And so what does it mean to say prisoners per 100,000 in the population? It would say that in the United States, for every 100,000 people, and let's just add here, in the United States, there were 600 in, I'll just say in prison, incarcerated, it might include prison and jail, in the year 2005. So that's what this is saying. And like I said, I think we have definitely moved up on that. I think we're over China and India at this point. All right, next little section here before we get into the Cartesian coordinate plane is just looking at some misleading graphs, because boy, I tell you, they are everywhere. These are some kind of dated graphs. I definitely have seen some more current ones that one of these semesters when I have more time, I will update some of my graphs, but misleading graphs are everywhere. So when you look at this graph, it really looks like Chevy is much, in this case, trucks sold that in the last 10 years that are still on the road. So it looks like Chevy trucks, there's a lot more of them still on the road, ones sold in the last 10 years than quite a bit bigger than Ford, a lot bigger than Toyota, and much, much bigger than whatever that small one is, Nissan, something or other. Hey, but if one starts to look a little more closely here on this y-axis, so take a look at those y-axis labels here. I'll put a little asterisk off to the side. So when you look at what they've done on this graph, I guess I'll just kind of real loosely kind of say here, they've kind of just zoomed in on the tops of the bars. Now that's a real loose way of saying this, and that's what makes the differences look more dramatic. So specifically, so they've zoomed in on the tops of the bars. So let's be a little bit more specific here. Specifically, the y-axis goes from, that y-axis starts at 95%. It goes from 95 to 100. And so when you start that y-axis so high, that's going to really make those differences look more dramatic. Okay, so that's what's misleading, and so this makes the differences look more dramatic. So that's just something to kind of like be on the lookout for when you're just in your day-to-day lives encountering graphs. It's kind of so common. I have another example. This was a case a number of years ago, probably over 10 years ago at this point. A lot of you may not be familiar with this one, but there was a case, and I don't have that information written here, but there was a woman in Florida. Her name was Terry Schiavo, and they wanted to remove her feeding tube. Her husband did, and I think it was her parents that didn't want that to happen, because obviously then the state she was in, that would have led to her death. And so they did a poll here about, and they broke it down by party about whether or not they agreed. I assume this was agreeing with the removal of the feeding tube or not. And so the first graph, let's focus on the graph. This is the first graph kind of released by CNN USA Today. One of the things that I would say is kind of bad about this one is they didn't give any label on the y-axis. So first, let's just kind of note a good graph should always have labels on the x and the y-axis. So when they just say 0 to 100, what are they talking about here? I don't really know for sure that they're talking about a percent. So when there was no y-axis label, kind of a little bit of a problem here. They should always have labels. They do remedy that over here. They add it as a label when they fix the graph. So when they correct it, they do. But more importantly, this is the same issue as before. So I'll say second and most important is going to be that the y-axis, once again, they've kind of zoomed in on the top of the bars. The y-axis goes from just 53, so just below the bottom bar, up to 63, just above the top bar. And that makes these differences look so dramatic. Okay, so then they had to fix it, and now they have kind of a more appropriate graph. So before, kind of the graph that they had, it was going, what did I say, from like 53 to 63. So it's almost like they were taking like just this part of the graph, like just this little bit here. And initially, that is what they just sort of zoomed in on and blew up on that graph. And that's why those differences start to look so extreme. And then they fixed it, and now it's like, the impression of the first graph is that Democrats are kind of way different than everybody else. And then when you kind of put it in perspective, you realize people aren't that different. Yes, there are some differences, and the data shows that, but the quick appearance is no longer so misleading. So just something to be aware of there with misleading graphs. And when we come back next time, we're going to get into the Cartesian or the coordinate plane. And this is really where we're going to start with the real important foundations of this chapter next time.